All right, everybody, welcome to Math with Grace.
Today we're going to be working through Algebra, Unit 7, Lessons 11 through 15. Lesson 11 begins on page 49, and it's titled Equalities Between Interest Applications. And we first looked at interest applications here in Unit 6, Lesson 13. Okay, so I put that there as a note. And it says, just as with the distance formula, the interest formula, interest equals principal times rate times time, can be used to algebraically express unknowns. This makes it possible to set up an equation to solve a word problem that involves money and interest rates. So let's take a look at example number 1 here that they have on the page. Solve this word problem, okay? 1 year, Brian invested money in a bank account, earning 4% interest, and lent money to a neighbor. So he did 2 different things, okay? And he lent the money at 3% interest. If the total amount of money earning interest was $5,000, so that's how much he not only invested, but he also lent, okay? The total amount that he had was $5,000, and he earned $185 in interest for the year. How was the money divided between the bank and the neighbor? So we know that the bank, let's call this first account the bank, okay? For that interest rate, it's going to equal the principal times the rate times the time, right? And for the neighbor, it's the same thing, okay? The interest is going to equal the principal times the rate times the time. Now, together, those 2 interest rates totaled $185, okay? So he earned a total of $185 in interest. So here is the basic equation. Here is where we start. The interest of the bank account plus the interest from the neighbor equals $185. Now that we have that set up, we can change this interest over back to the principal times rate times time. Remember, when we're doing time, it's always in years. So if they don't give you an actual year amount, now this one says 1 year, so we're fine. But you need to figure out what that would be if they don't give it to you as a year time frame, okay? So now we're down to this equation, right? The principal of the bank times the rate of the bank times the time of the bank plus the principal of the neighbor times the rate of the neighbor times the time of the neighbor, okay? Now here's what we don't know, right? We don't know the principal. We know the rate at the bank was 4% interest. We know that the rate to the neighbor was 3%. Okay, so here's the 3%, here's the 4%. We know that both of these were over a 1 year period. So there's the 1 for that total, right? But what we don't know is the principal of each. And here's where it gets a little bit confusing for some people. What we do know is that the principal of the bank plus the principal of the neighbor equals $5,000. $5,000, right? Because that's how much money he invested. He invested in the bank and he invested in his neighbor. So what we need to do then is solve for one of these. Whether we solve for the bank or the neighbor, when you're working on these, it really doesn't matter. The second account, they considered their bank account because it has the 4% here. I am kind of written the wrong way, but that's okay. So that's the one that they decided to solve for. They decided to solve for the neighbor, okay? Because the neighbor earned 3%. So that one gets to keep its principal. And if you solve this problem right here for neighbor, what would you have to do? Well, you'd have to subtract the principal of the bank from both sides, right? And you would get that the principal of the neighbor, I'm just going to put N, is equal to $5,000 minus the principal of the bank. Okay, and that's what they did right here. So they solved for the neighbor, who was at 3% interest rate, and this is what they got. Now they could substitute. Now they know that the neighbor is equal to 5,000 minus the bank. They could substitute that in, and now we have the same variable here, and we can solve this problem, okay? They're going to distribute this 0.4 through, and then they calculate it out, and they find that the amount that he loaned his neighbor at 3% interest rate was $1,500, okay? So if he loaned $1,500 to the neighbor, if we take $5,000 and subtract $1,500, we'll see that he put $3,500 into the bank. Okay? Let's turn the page and look at a couple of these problems. So at the top of this page, just like with the distance problems, they have a few ways that these problems can come together, a few ways in which they can be related to each other. So keep that in mind as we're working through some of these. So number 1, a banker invests $500 more at 6% interest than he does another investment at 5% interest. So he's got two investments, okay? One's at 6%, one is at 5%. If he will receive $910 in interest in 1 year, how much were the two investments? So investment 1, the interest for investment 1 plus the interest for investment 2 together total $910, okay? That's what we know. And remember, interest equals principal times rate times time, okay? So the interest of one plus the interest of the second investment totaled $910. Now we need to go back and work at this. So we have investment 1, okay, plus investment 2 is going to equal that total, right? We've already said that this was our formula. So now we're going to break it down into our principal times rate times time, okay? For the principal of investment 1, he invested $500 more at 6% than he did at another investment. So the other investment is our X, right, for the principal. And so this one is going to be X plus 500 because he invested $500 more than the other. So investment 2 is our base. And for investment 1, it's $500 more. So what's the rate of investment 1? Well, it's 6%. How do we write 6% as a decimal? To use in a problem, remember, we want to move our decimal over 2 places. 2 places. So it's 0.06. And then our time is simply that 1. Sometimes I don't list it when they say that it's a year, just because multiplying something by 1 is just 1, right? So sometimes I forget to list it, but it is that 1 year. So now let's take a look at interest investment number 2, right? The principal we've already decided was X. What is the rate on investment 2? Well, it's 5%, so 0.05. And the time for that one, again, is still 1 year. And the total, remember, was $910. Now we've broken it down, right? Investment 1, investment 2. Here are the different parts, okay, that make up the equation. Here are its parts. We now simply need to bring them together. We need to make sure we distribute this 0.06 throughout, and so we don't miss something. So 0.06 times X is 0.06X. 0.06 times 500 equals 30, okay? And then we have plus X times 0.05, so 0.05X times 1, which is just 1, right? Or the same answer. So equals 910. Now we combine our like terms, which are these X's, okay? And we get 1.1X plus 30 equals 910, right? We need to get this X by itself like usual. So we're going to get rid of this 30. It's a positive. So we're going to do the opposite and subtract 30 from both sides. Okay. And I'm just going to skirt it over here. 1.1X is now equal to 910 minus 30, which is going to be 880. Okay. 1.1 is being multiplied by X. We're going to do the opposite and divide. Okay. And when we do that, we divide 880 by 1.1. We get that X is equal to 800. Now, before we just finish and just walk away from this problem, what did we solve for? Okay. And what was the question? It says here, how much were the two investments? Okay. So I actually need 2 answers for this problem. There were 2 investments, so I need 2 answers. So we solve for X, which was actually investment 2. So investment 2 is equal to $800. And this is kind of a tight squeeze here. And if investment 2 was 800, we know that investment 1 was $500 more than that. So investment 1 is equal to 800 plus 500, or $1,300. Okay, so investment 1 was $1,300 and investment 2 was $800. All right, we started with this simple formula right here and just kept spreading it out basically until we got to where we could solve. All right, let's take a look at number 2. In saving for a car, Jill earned $114 in interest by investing the same amount of money for 1 year into 2 different banks. One paying 4.5% interest, the other paying 5% interest. What was the total amount she invested? Now it says here, hint, the total of the 2 interests was $114, which is what they already told us. So we know that the interest from bank 1, okay, plus the interest from bank 2 equals $114, right? It's what she earned in her 1 year. Now we can split these up into our principal times rate times time formulas, and see what we get here. So she invested the same amount of money. This is our hint, okay? So her principal for each account was exactly the same. So that's our X. So the principal for bank 1 is X. The rate for bank 1 was 4.5%, okay? 4.5%. We want to write it as a decimal. We have to move our decimal place 2 places. So 0.045 times 1 year, right? Plus our bank 2 information. Well, the principal for bank 2 is exactly the same, so it's another X, right? The interest for bank 2, though, is at 5%. So 5%, we move our decimal 2 places, we get 0.05. And then we have our 1 for our 1 year. And altogether, that's $114. Now we need to just multiply this out, right? We have 0.045x plus 0.05x equals 114. We combine our like terms, and we have 0.095x equals 114. X is being multiplied by 0.095, so we're going to do the opposite and divide. Okay, and we end up with X is equal to 1,200. Now, again, what is our X? What did we solve for? Well, our X was the principal that she put into each bank account, right? But the question is, what was the total amount she invested? Well, she invested $1,200 here and $1,200 here. So her total investment was equal to $2,400. Okay, double, because she invested this much into 2 different banks. All right, so when you get to the bottom here and you've actually solved for X, go back into the question and make sure you're answering what the question is asking, because sometimes they're asking something and that's not quite what you solved for, but we can get there with your solved information, okay? Let's look at number 3. Greg invested $7,000 in one company and $5,000 in another. If the rate of return was 2% higher, so that's your interest, for the first investment, he earned a combined total of $370 in interest for the first 6 months. What was the rate of return for each investment? Now, the rate of return is your rate, is your R in your formula. It says here, remember to express time in years, not months. They've given us 6 months, so we need to make sure we express that as 1/2 of a year, okay? But what do we have going on here? Well, we have an investment in one company, let's call it company, plus the interest, sorry, in the other company, we'll call it A for another, right? We got company and we have another, all right? The interest for both of those was a total of $370. Okay, that's the total interest that he earned over 6 months. Now we can break this apart, okay? Using our, and it's missing, it doesn't quite fit on the page, but interest equals principal times rate times time, okay? So interest for company. The first company, we decided that his principal here is $7,000. That's our company number C, our company letter C, right? The rate for that, okay, they don't really tell us, but it says if the rate of return was 2% higher for the first investment, so since we're choosing this as our first investment, that's what we're going to do. So it's 2% higher than the other investment. So the other investment is our base, and therefore the rate of this one is X, the base, plus 2% or 0.02. All right. And then what is the time? Remember, we have to express it in years, so it's 1/2. Now you could put 0.5, because that's the same as 1/2, right? Since we're doing a lot of calculator work here, that would be fine. Now for the another company, okay, his principal was $5,000 for investment into there, times the rate, which we decided that one was our base rate, so X, because that's what we're solving for. And again, don't forget the time, times the time, which is 1/2. Okay, it's a half of year. And altogether, again, $370. Now, because I wrote 1/2, to get rid of that fraction, I'm going to multiply the whole entire equation, which means every part, by 2. So when I multiply this first part by 2, this is canceled, right? When I multiply this term here by 2, it gets canceled, but I also have to multiply this term by 2 as well. So now I have 7,000 times X plus 0.02 plus 5,000X, right? Because now that 1/2 is gone, is going to be equal to 2 times 370, so $740. Okay, all I did was get rid of this fraction. I canceled it here, but I have to multiply this part by 2. You have to multiply every term by 2. It canceled with these 1/2, but on this one we have to, this is the one most people forget. Don't forget that term as well. Just because it's on the other side of the equal sign, we still have to multiply it as well. Okay. Now we need to use our distributive property, and we have 7,000x plus 7,000 times 0.02, which is 140, plus 5,000x equals 740. All right. We're going to combine these like terms. So 7 plus 5 is 12, right? So now we have 12,000 x's plus 140 equals 740. We need to get rid of this 140. It's positive, so we're going to do the opposite and subtract it from both sides. And we're left with 12,000x is equal to 600, right? 40 minus 40 is 0, 7 minus 1 is 6, so 600. Now you're looking at this probably like, man, that 12,000 is big. But remember, we're solving for an interest rate. So what we should be left with is a decimal that we can change into a percentage, right? So 12,000 is being multiplied by x, so we're going to do the opposite and divide. And when we divide 600 by 12,000, we see that x is equal to 0.05. Now, let's think back of what we're trying to figure out. What was the rate of return for each investment? So what is the rate, the interest rate for each investment? We solve for x, which is the rate for this one, right? So that was our rate of our investment A is 5%, right? If we multiply this by 100, we get 5%, changing it from a decimal back to a percentage rate. So then the rate of our company, since that's how we labeled them, right, was 2% more than that, so 7%. So that is what we were solving for this time, was the rate. Okay, this time up here, we solved for our principal. Up here, we solved for principal again, I believe. But sometimes we are going to solve for the rate. Sometimes we might even solve for the time. Okay, it doesn't, all of those things work together, and they're all parts that we can figure out. So remember, when you're solving for the rate and you get a decimal, you need to multiply that by 100 to get it back to a percentage. Okay, because we're talking about interest rates, which are percentages. All right, let's take a look at number 4. Frederick has funds he can invest in a simple savings account yielding 3% annual interest rate. If he had $1,500 more, he could then invest his funds in a CD account paying 5% interest rate and earn an additional $145 in 1 year. So how much money does he currently have to invest? Now it gives us a hint here that says, create inequality between the two interest possibilities. So looking over the question again, he can invest in a simple savings at such and such a percentage. But if he had more money, he could invest in a CD and earn another $145 in 1 year. So that tells me that the interest from the simple savings plus that $145 would equal the interest from the CD. Okay, so I put simple savings and I have the interest from the CD. Remember that interest equals principal times rate times time. Okay, so that's what they're saying here. If he had more money and could invest in a CD, he would make an extra $145 on top of what he would have made in the simple savings account. So that's how we know how to set up this equation. That's our beginning point. So now we can break it down to our principal, rate, and time, okay? So for our simple savings, the principal is what we don't know, right? How much money does he have? We don't know. So that is our X, okay? What is the rate of our simple savings? Well, it's 3%, so that's 0.03. And the time is, it's going to be a year is what it looks like, because they don't give us a time frame. So we are going to assume that that time is 1 year. 1 year. Oh yeah, it says annual interest rate. So annual means a year. So that is the interest for our simple savings plus $145. Okay, is going to be equal to the interest for our CD account. Now, what is the principal for our CD? Well, we didn't know the principal here, right? But we know that to buy the CD, he would need the amount of money he has now, plus that $1,500 extra dollars, right? He doesn't have enough to buy the CD. He needs $1,500 more. So it's whatever he has now, plus $1,500 is what he would have put in the CD. What is the rate for the CD? Well, it's 5%, so 0.05. And again, we have 1 year. Okay, so now we have our problem set up. Once we get to here, breaking it apart is the easy part, right? Principal times rate times time. But if you still are stuck between this step, maybe you're stuck on this step, maybe you're stuck on this next step, please let me know. I'm happy to help. Now we need to distribute and multiply all this out. So we have 0.03x plus 145 is going to be equal to whatever we have over here, right? The 1 we can disregard because it's a 1. So we have to distribute this 0.05 through here. So we end up with 0.05x plus 0.05 times 1,500, which is 75. Okay, now looking at this, we need to decide, since we have an X on both sides of the equal sign, we need to decide which one's larger. Is it 0.03x or 0.05x? Well, it's the 0.05, right? So we'll move the 0.03. So we're going to subtract this one from both sides because we want to try to keep our variable positive, right? So now we have 145 is equal to 0.05x minus 0.0, and we have now 0.02x plus 75, right? We need to get this x by itself, so we need to move this positive 75. So we're going to do the opposite and subtract 75 from both sides. I'm quickly running out of paper here. So I have 0.02x equal to 145 minus 75, or 70, okay? 0.02 is being multiplied by x. We're going to do the opposite and divide. And we find that our x is equal to 3,500, right? We're taking a fairly large number, dividing it by a pretty tiny number. So we end up with 3,500. Now, what did we solve for, and what are they looking for? We solved for the principal right here in his first investment, in the simple savings. So how much money does he currently have to invest? Well, it's whatever amount he had to put into his simple savings. So he has $3,500. That's how much money he has right now. If he had $1,500 more, or $5,000, he could invest in that CD, right? But he doesn't. He only has $3,500. And so that's what we solved for this time. Just our answer was our answer. Make sure you put dollars because we're talking about money. So working on these, we want to find the relationship that we have between these interest accounts, okay? 9 times out of 10, it's going to be the interest, right? Here's our examples. The interest is equal to the interest, or the interest plus the other is equal to a number. Those are, this someone is the one we probably get the most. And then once we've figured out that relationship, then we can break it apart, okay, to the interest formula and solve. All right? Again, if you have problems setting these up, because I know story problems can be tricky for some people, please let me know. I'm happy to help you get them set up. All right? That's lesson 11. Lesson 12 begins on page 55, and it's titled Graphing Linear Inequalities. And it says, because solutions to inequalities do not result in just a line, graphing a linear inequality is a little bit more complicated or involved than graphing a linear equality, right? When y equaled x, it just became a perfectly straight line. But if we have the inequality that y is greater than or equal to x, at each point we have a set of values that is equal to that solve it, right? So what happens is, to show all the solution points for an inequality, which is, remember, less than or equal to, greater than or equal to, less than or greater than, right? Those are our inequalities. So to show all of the points of an inequality, we actually shade a region of our graph. It's not just going to be a line. We need the line, because that shows our boundary, but we're also going to shade an area, because if y is 3, it's going to be greater than when x is 1, right? This point here, 1, 3, y is always going to be greater, because 3 is greater than 1, right? So it's going to be shaded in. It doesn't fall on this line, but it's still part of the solution, okay? So when we're talking about inequalities, now we're shading our graphs. Let's turn the page. Now, just like when we did the number line and we had an open circle or a closed circle, we have to show in our lines as well whether or not that line is included. So when you have a greater than or equal to or less than or equal to symbol, we will have a solid line with our shading. But if we have a less than or greater than symbol, then technically the solutions that fall on the line aren't included in this actual solution, and so we end up having a dotted line, okay? So if it's greater than or less than, there's no equal, then we have a dotted line at our boundary, and then we shade in the part of the solutions that work, okay? The symbols for, if the symbols are greater than or equal to, the solutions are above the line. So when we have something that's greater than or equal to, we're always shading above the line. And a lot of times I will put an arrow to show which way we need to shade, because as we move forward, we're going to be shading more than one line at a time on a graph. Now, when the symbols are less than or equal to, the solutions below the boundary line are shaded. Okay, so greater than or equal to, it's above. Less than or equal to, it's below. Now it says here, when we have a vertical boundary line, so x is greater than or less than or whatever, equal to something. If x is greater than or equal to, then we shade to the right, okay? If x is less than or equal to, then we shade to the left. This is kind of what this section says, but I don't like the way they said it, so this is much easier, okay? Greater than or equal to the right. Less than or equal to the left, okay? So let's take a look at a couple examples, and then we'll do a couple of these together. So graph the inequality y is less than or equal to -1/2 x plus 1. Okay, first thing we need to know, right? What is our y-intercept? Because that's where our line starts. Well, remember, our y-intercept is this b. So we are going to be starting at +1 on the y-axis. So we went up there and they put a dot, okay? Or I'm putting a dot anyway. Then we need to know our slope. Our slope is a -1/2, okay? That tells us if we are walking from left to right, because it's negative, we're going to be going downhill. And because it's negative, we're going to go down 1 to the right 2. And that's going to be our next dot, okay? Now we have to decide, since we just put these 2 dots, do we put a dotted line or a solid line? Well, it says y is less than or equal to, so we put a solid line. All right, so that is our boundary line. We've drawn the line. Now we need to shade where the shading needs to go. And because it's less than or equal to, we are going to shade underneath. And so that's what they did here. I don't care. You don't have to fill in this. I mean, if you just went like this, I'd be content with that, okay? As long as I understand where your shading is, that's fine. Some people like to be very meticulous. That's fine too. But you do not have to shade in every inch of space, okay? Just make it known that I know where you're shading, and that's great. All right, let's look at example 2. They want us to graph the inequality 5x minus y is less than 2. Now, this is not in the standard form for us to be able to solve it, so we need to solve for y and put this into standard form. So that's what they did here. They subtracted 5x from both sides, but we can't have a negative y, so they divided everything by a -1. And when they did that, remember, when you divide or multiply by a negative, when we're talking about inequalities, it flips the sign. It would have been like if we had done it this way, 5x minus y is less than 2. Visualize it like this. If we had added y to both sides first, right, and you would have 5x is less than 2 plus y, and then subtracted this 2 from both sides, we would have that y is greater than 5x minus 2, right? Well, that's what we have. They just wrote it so that the y stays on the left-hand side, because that's how the formula is supposed to be, right? Y equals mx plus b. If you don't remember this formula by now, you will, because we will continue to use it over and over and over. So now that we have it in slope-intercept form, we need our b, right? And our b was this -2. So we go on the y-axis down 2 points, 1, 2, and we put our dot. And what is our slope then? That's what we need to know next, right? Our slope is a +5. Well, remember, that's a 5 over a 1. It's positive, so we're going to be walking uphill from left to right. So we go up 5 points. So 1, 2, 3, 4, 5, and over 1 point, and we put our next dot. Now we have to decide, is this a dotted line or a solid line? Well, my y is greater than, not equal to, so it's a dotted line. And that's why they have the dotted line. And because it's greater than, we want to shade on top of our line. I mean, think about if, and I know it's kind of hard to look at this one and think that this is the top because it almost looks like it's going straight up. But if you were to stand on it and be walking up this mountain, this steep hill, right? Which part would you be standing on? You'd be standing over here, okay? So that's the top of the line, and that's what they shaded. All right, so let's turn the page and do some of these together. So page 58, number 1, y is less than or equal to negative 1/3 x plus 3. So plus 3 is where we start. That's so nice of them to give us these nice little graphs. So we are going to go up 3 points on our y-axis and put a dot. All right, that's our beginning point. Now our slope is this negative 1/3. So from left to right, we're going to be going downhill, and we go down 1 to the right 3. And that's our next dot. Now we're going to connect these dots, but with what kind of line? Do we want a straight line or solid line, or do we want a dotted line? Y is less than or equal to, so that tells us we want a solid line. Okay? So that is our boundary. We just plotted that line. Good job. That's our boundary, right? So now, where do I shade? It tells me here that y is less than or equal to, so I want to shade underneath the line. And so I want to shade this part, okay? And like I said, you do not have to shade it in any amazing way. You can if you'd like to spend your time on that. Some people like to do them in color. I don't, however you want to do it, as long as I can tell which part is shaded, that's all that matters, okay? For number 2, y is greater than 8x minus 4. Okay, first we need to figure out where our line is going to be, and then we can shade. So we're starting here at this negative 4. So at the origin, we count down 4 points. 1, 2, 3, 4, and that's our first dot. Then our slope here is 8, or 8 over 1, and that tells us it's positive, so we're going to go up 8 over 1. So 1, 2, 3, 4, 5, 6, 7, 8, and over 1 point. That's my next dot for my line. Now, before I draw my line in, is it going to be solid or dotty? Well, y is greater than, so that tells me it's a dotty line. There's no equal sign as part of our inequality, so it's a dotty line. So then you just draw it, you know, as a dotted line. Just like that. Sometimes I forget, and then I just go and erase little chunks of it. That works too. But that's a dotted line. Now, which side do I shade? Where is my shading going? Well, my y is greater than. So if I was walking up this steep mountain, I'd be standing on this side of the line, right? So that is where we shade. Now, you could always test this by picking a point on either side of the line. So let's pick the point 1 or negative 1, 1, right? Right here is the point negative 1, comma 1. And let's see if it fits into this equation, if it makes this equation true. Is 1 greater than, because 1 is my y, 8 times negative 1 minus 4. So is 1 greater than negative 8 minus 4, which is a negative 12? Yeah, 1 is greater than negative 12, so we have shaded the correct side, okay? Always a way to check your work. And so if you're not sure which side to shade, pick a point on either side. My shading went a little wide, crazy there. Pick a point on either side and solve and see if it works, okay? We'll solve another one and check our graphing here on one of these next ones as well, just so you can see it again. For number 3, we have x plus 3y is greater than 6. Now, this is not in our proper form, y equals mx plus b, right? So we need to put it in that form. X is positive, so we're going to do the opposite and subtract it from both sides. And we're left with 3y is greater than negative x plus 6. I like to write the x first because that's just the way the formula works, right? Now, 3 is being multiplied by y, so I'm going to do the opposite and divide each part. Every term has to be divided by that 3. Y is now equal to, not equal to, sorry, y is greater than. I want to pull, this is negative x over 3, right? Or basically negative 1x over 3. I want to pull that fraction out. So it becomes negative 1/3 x. Okay, so the x is kind of sitting outside of it, but it's still part of it. That way we can tell what our slope is. And then 6 divided by 3 is 2. Now we have it in the proper form. We can start by plotting our b, our y-intercept. and that's at a positive 2. So I go to the origin and up 2 points, and I put a dot. Then I look at my slope. My slope is a negative 1/3. So rather than go up and to the right, I'm going to go down and to the right. So down 1 and over to the right 3. 1, 2, 3. That's my next dot right there. Now, is my line solid or a dotty line? Well, my y is greater than, so that shows me that I have a dotty line. So I'm going to line up my straight edge here and dotty, dotty, dotty. Dotty line. Okay, now where do I shade? Well, y is greater than all of this. If I was standing on this, walking down the hill, I'd be standing on this side, and that's my greater than side. Okay, let's check a point. Let's check the origin point, which is 0.00, right? Let's check it and see if it fits the solution. It shouldn't, right? Because that's not the side I shaded. So let's see. Is 0 greater than, because my y is 0, negative 1/3 times 0 plus 2? Well, negative 1/3 times 0 is nothing, right? So is 0 greater than 2? No, it is not. 0 is not greater than 2. So this side is not the side that should be shaded. So we shaded the correct side. So sometimes it's okay to check the opposite side as long, it didn't work out. So we shaded the correct part because this is not a solution for this equation. All right? Let's look at number 4. X is greater than negative 1. Now this is going to be a straight horizontal line or a vertical line, right? And it's at negative 1x. So we can go, here's my negative 1x. Solid or dotty though? We have just a greater than, so it's a dotty line at this negative 1. And so it's going to look like this. Okay. Now, which side do we shade on? X is greater than this negative 1. So remember when I told you on the other page, when we're greater than, and it's a vertical line, greater than means to the right. And you can test that by picking a point here. If x is 5 greater than negative 1? Yes. Okay, that one's an easy one to test. All right, last two. Number 5. Y is greater than or equal to a negative 3. Now, we have a line here, straight line again, but this time it's a horizontal line. At y is negative 3 because for every value of x, y is negative 3 now. It's a solid line because we have our equal to. Okay, it's greater than or equal to. But now where do we shade for this one? Well, if we were standing, it's greater than. So if we were standing, we're going to be standing on the greater than side. We want to shade above the line. Okay, so that's the shading for that one. They gave you 2 easy ones in a row. Let's look at number 6 now. Obviously, number 6 is not in our correct slope-intercept formula, so we need to get it there. We're going to start by subtracting this 3x from both sides. So now I have 2y is greater than a negative 3x. 2 is being, and the 0 is just whatever. 2 is being multiplied by y, so we're going to do the opposite and divide. Now, remember, I want to pull the x outside of this fraction. So y is negative 3 over 2x plus 0, which is our y-intercept, right? The 0 is where we're starting. Since it's not anything, it's just a 0, we're literally starting at the center, at the origin point. Now, our slope is negative, so going from left to right, it's going to be downhill, and we're going to go down 3 to the right 2. So down 3, 1, 2, 3, to the right 2. We put our point there. Oh, and I wrote equals. My bad. It's y is greater than. So since y is just greater than, but not greater than or equal to, we are going to have a dotted line. Okay. As such. Now, where do we shade? Well, y is greater than, so we want to be above the line. So if we were standing here walking downhill, we would be walking above the line, which is this side. Okay? So first step is to figure out where your line would be, right? Graphing the line just like we have been doing all along with starting with our y-intercept. Let's look at this number 1, starting with our y-intercept point, right? And then plotting our slope. Then we need to decide, is it a dotted line or a solid line? And that's based on our inequality, right? Greater than or equal to, less than or equal to is going to be solid. Less than or greater than is going to be dotted. Once that's done, we need to decide which area to shade. And that's all based on whether it's greater than or less than. Okay, greater than above, less than below. All right, great job. Lesson 13 begins on page 63, and it's inverse variations. Now, we talked about direct variation before, right? So a direct variation was if x then y, right? Well, now we have an inverse variation. And an inverse variation, if we solve this for k, then it would look like yx equals k. So y times x equals k. So the direct was y over x. The inverse is y times x, okay? So the dependent variable decreases as the independent variable increases. That's the difference here. And this is called an inverse variation. It's represented by y equals k over x, or x times y equals k. This is the version that we're going to use. Y varies inversely as x. When you read that, you should be writing this. Okay? So let's take a look at these equations. If y varies inversely as x, so we have y times x, and y is 4, when x is 3, they want us to solve for the constant, but let's look down here. Y is 4 when x is 3. What is y when x is 2? This is the way we're going to set these up. We're not going to solve for the constant because it's a waste of time. So 4 times 3 is 12 equals 2y, right? 2 times y is 2y. So 2 is being multiplied by y. We're going to do the opposite and divide. And we see that y is equal to 6. Okay? So when x is 2, y is 6. So in these cases, my x decreased, so my y increased, where before in the direct variation, it was the opposite, right? If one went down, the other went down. If one went up, the other went up. This is going to be inverse. It's a different relation. So let's turn the page. Let's take a look here at example 2. I don't care about the constant of the variation. They almost never actually ask us for that in an actual problem. So let's see what it says. Time is inversely proportional as speed. So time, speed. Okay? Time times speed. If you normally bicycle to a neighborhood city 3.5 hours away at 10 miles per hour, how fast would you have to ride to get there in 2.5 hours? So now we have our time and we're solving for our speed, right? But think about it like this. If it takes you 3.5 hours to get there at 10 miles per hour, to get there in less time, you're obviously going to have to be traveling faster, right? That's how distance works. So we've got 3.5 times 10, which is 35, equals 2.5 times, I'm going to keep it in parentheses because my 5's and my s's look a lot alike. I apologize. So 2.5 times s, we're going to do the opposite and divide 2.5. And we find out that our speed would have to be, what is it right here? 14. Okay. So instead of going 10 miles per hour, we'd have to go 14 miles per hour. It's pretty fast on a bike. This time decreased, so this speed had to increase. That's the difference with the inverse variation. So let's do these 4 problems together. Number 1, if y varies inversely as x, so I have y times x, and y is 5 when x is 3, what is, that's our equal sign, y when x is 30? Okay, there, we read the story problem and we wrote it down as we read. Y is 5, x is 3, what is, equal sign, y when x is 30? Well, 5 times 3 is 15 equals y times 30, right? We're going to do the opposite here and divide both sides by 30. And we see that y is equal to 15 divided by 30, or 1.5. Okay, you could write 0.5, that's fine. But the answer is 1/2, right? 15 over 30 is 1/2. 15 divided by 30 is 0.5. That works out too. So y is 1/2, right? Let's look at number 2. If b varies inversely as a, so b times a, and b is 12 when a is 7, what is, that's our equal sign, b when a is 2? All right, let's solve. 12 times 7 is 84. 2 times b is 2b. So 2 is being multiplied by b. We're going to do the opposite and divide. And we see that b is equal to 84 divided by 2, or 42. Okay, so our a decreased, so our b had to increase, right? One goes down, the other must go up. That's how these inverse variations work. All right, if y varies inversely as x squared, so our basic formula is y times x squared, and y is 2.5, when x is 2, it's 2 squared, okay? What is y when x is 5, or 5 squared, because that is our formula? So we've got 2.5 times 2 squared, which is 4, is equal to y times 5 squared, or 25y. 2.5 times 4 is 10. Okay, 25 is being multiplied by y. We're going to do the opposite and divide. So we can see here that y is going to be equal to 25, or 10, sorry, over 25, which would be, if we took a 5 out of each, which would be 2 over 5, 2/5. Or let's find the fraction, sorry, not the fraction, the decimal, 0.4. Okay, it is okay to write a decimal for these types of problems. That's probably more correct answer. So 10 divided by 25, or 2 divided by 5, both of them come up to 0.4 would be our y. All right, our x increased, okay, went from 2 to 5. So our y had to decrease. It went from 2.5 down to 0.4. That's why it's okay to put a decimal, because we started with a decimal, right? All right, last one, number 4. The weight of an object varies inversely as the square of its distance from the center of the earth. Oof, that's quite a mouthful, right? So the weight varies inversely as the square of its distance. Okay, so that's it. All of that, blah, blah, blah. Distance from the center of the earth, great. So the weight is inversely related to the distance squared. James weighs about 200 pounds on the surface of the earth. Okay, so his weight is 200 pounds at the surface of the earth, which is 4,000 from its center. So that's 4,000 squared. Okay, because our distance are squaring it. How much would he weigh in an airplane, so we don't know the weight, flying 5 miles high? Well, what is its distance from the center of the earth? Well, first we need to figure out how far 5 miles is, right? We can't add, oh, I guess we can, because this is 4,000 miles, silly me. Okay, we can add 5 miles to 4,000 miles. So it's going to be 4,005 miles, right? Squared. Do not forget the squared, because that is the relationship. That is their inverse relationship. So these numbers are going to be kind of huge, right? But that's okay. So we have 200 times 4,000 squared, or 16 million. Okay, make sure you get your zeros in there. So then what is 4,500 squared? Not 4,500. What is 4,005 squared? Well, that is 16,040,025 W's. Okay. Now we need to take our 16 million here and multiply it by 200. So that gives us 3,200,000,000. 16,040,025 W's. Okay. The numbers are big, but don't let them freak you out. Take it slow. This 16,440,025 is being multiplied by W. We're going to do the opposite divide, right? So 16040,025 divided by, on both sides, 16040,025. And let's figure out how much he weighs on an airplane. And that answer is 199.5 pounds. Okay? He weighed 200 pounds on the surface of the earth. Okay? But as he got farther away, his distance got greater, was increased, his weight had to decrease. And it decreased by half a pound, right? So how much more did he weigh? How much, or it says how much does he weigh in the airplane? He weighs 199.5 pounds. He lost a half a pound by flying 5 miles from the center of the earth. Congratulations, James. Okay? These numbers are pretty huge. Don't let it freak you out. Just take it slow. Use your calculator, of course. The whole purpose here is when we have an inverse relationship, we're multiplying two things, okay? And when we're doing it in this way, when it says, what is, that's our equal sign moment, okay? Y is 2.5 and X is 2. What is Y when X is 5? Okay, in this case, we had to square our X, but that's okay. And we solve, all right? Great job. That's lesson 13. All right, our last lesson, lesson 14, begins on page 69, and it's dividing a trinomial by a binomial. This is long division for polynomials. That's basically what this is. So division of a trinomial by a binomial can be accomplished using a pattern similar to long division. The key is dividing only the first term of the divisor into the first term of the dividend to find the quotient. So I set up this so that you could understand what this meant if you weren't sure. Divisor's on the outside, the dividend is in underneath the division bracket, and the quotient is your answer, right? So looking at example, just jumping right in here to this first example. Divide 6x squared minus x minus 15 by 2x plus 3. So here's the setup. This part goes under. The first one goes underneath, and the second one goes here on the outside, okay? The second one is the divisor. The first one is the dividend. Now, to figure out how to do this, it says divide only the first term. What we want to look at are these first terms, okay? What do we need to multiply 2x by to get it to be a 6x squared? What do we multiply 2x by to get it to be a 6x squared? Well, to get the 2 to be a 6, we'd have to multiply it by a 3, right? And to get this x to be an x squared, we'd have to multiply it by an x. So basically, our first quotient is 3x, because that is going to get us to this. So now we actually do that multiplication. We take 3x times 2x, and we get 6x squared. We take 3x times this 3, because now this takes part, and we get 9x. All right? The next step here is to change the signs. This positive 6x squared becomes negative, and this positive 9 becomes negative. We change the sign. Now, if one of them was negative already, we would make it positive, right? And now we can subtract. Basically, we're subtracting this from this first part, okay? And so now we do that. Negative x minus 9x gives me a negative 10x. Positive 6x squared minus 6x squared gives me 0. This is the goal, that these cancel each other out. If you did this work and these do not cancel each other out, you've made a mistake somewhere. That is what our purpose is. These have canceled, they're gone. Now we're left with this 10x, negative 10x, right? This negative 15 falls down, just like long division you've done in the past, okay? So now we have Negative 10x minus 15. How do we get this 2x to be a negative 10x? Well, we would have to multiply it by a negative 5, right? Then you do it. Negative 5 times positive 2x gives me a negative 10x. Okay? Negative 5 times positive 3 gives me a negative 15. Then you change the signs. Positive, positive, and add them together. Negative 15 plus a positive 15 is 0. Negative 10x plus a positive 10x is 0. The whole goal is to get this to be gone. For now, they are giving us answers without remnants. There's nothing left over. There's no remainder. Okay? That's how they'll do it for now. Eventually, we will have remainders, but for now, we're going to have a remainder of 0. So the answer is this, 3x minus 5. Okay, it's important that the terms of both the dividend and the divisor are in descending order before you start this work. You don't want it to be written like 3 plus 2x and then have this be negative x minus 15 plus 6x squared. Okay, it can't be. It has to be written in descending order, meaning the largest x term, then the next one, and then the constant at the end. Okay, this is a no-no. Boo. All right, let's turn the page. So they don't give us a whole bunch of examples. They just throw us right in. So let's dive right in here. Okay, we have the quantity x squared minus 5x minus 14 divided by x plus 2. So we're going to rewrite this. So x squared minus, I didn't give myself enough room. Hold on a second. I had to get out the big eraser. X squared minus 5x minus 14 divided by x plus 2. Okay. So what do I need to multiply x by to get it to be an x squared? Well, I need to multiply it by x. Right? So then I do that. X times x is x squared. X times a positive 2 is a positive 2x. Then I change the signs. Okay? And I just write them right over top. Just like they did. I don't usually cross that one out because I can tell if I wrote a negative over a positive that now I need it to be negative. Okay? So change the signs. These cancel. Perfect. Negative 5x minus 2x is a negative 7x, and then this negative 14 drops down. The biggest problem that I have is people change the sign, but then they don't actually add them together correctly. So change the sign, make sure that's the sign you're using. It's not negative 5x plus 2x to give a negative 3. That would be incorrect. Okay? It's negative 5x minus 2x gives me a negative 7x minus 14. Okay. Now, how do I get this x to be a negative 7x? Well, I'd have to multiply it by a negative 7, right? Negative 7 times x gives me a negative 7x. Negative 7 times a positive 2 gives me a negative 14. Change their signs. Okay? Now, negative 7x plus 7x is canceled. Negative 14 plus 14, that one's gone too. We don't have a remainder. So our answer is x minus 7. Okay? These can be kind of awkward at first, but once you get the hang of it, they're pretty good to go. So we have x squared minus 9x plus 20 divided by x minus 5. So how do I get my x to be an x squared? Just like the one before, we're going to multiply it by x. X times x gives me an x squared. X times a negative 5 gives me negative 5x. Change the signs. Okay? X squared minus x squared canceled. Negative 9x plus 5x is a negative 4x. My positive 20 falls down like that. Now, how do I get this x to look like a negative 4x? I multiply it by a negative 4. Negative 4 times x gives me a negative 4x. Negative 4 times negative 5 gives me a positive 20. Change the signs. Okay. Negative 4x plus 4x, gone. 20 minus 20, gone. No remainder for this one, so our answer is x minus 4. All right. Now they're going to step it up a notch. Okay. we have 5s plus 2s squared, which of course we can't leave in that form. As soon as I wrote that 5s, I was like, wait a minute. We want the 2s squared first, plus 5s minus 3. That's why it's important to read the problem before you start writing it down. And all of that is divided by 2s minus 1. Okay, we had to rewrite this one so it's in the proper order, descending order, and now we're able to work through the problem. Okay, how do I get this 2s to be a 2s squared? Well, I'm going to multiply it by s, right? 2s times s is 2s squared. S times a negative 1 gives me a negative s, okay? S times negative 1, you could write negative 1s if it makes it easier. Change the signs, okay? I know my 5s and my s's look a lot alike. Sorry, they do that to me on purpose. All right, 2s squared minus 2s squared canceled, right? 5s plus s gives me a 6s. Then my negative 3 drops down. 6s minus 3. How do I get this 2s to look like a 6s? Well, this would have to be multiplied by 3, right? 2 times 3 is 6, so 3 times 2s is 6s. 3 times a negative 1 gives me a negative 3. Then I change my signs. 6s minus 6s is canceled. Negative 3 plus 3 is canceled. No remainder. My answer is s plus 3. Right? Number 4. 3x squared plus 6x plus 3 divided by x plus 1. Okay, that's how you write these. Now, how do I get my x to be a 3x squared? Okay, I would need to multiply it by a 3 and an x, right? So 3x times x is 3x squared. 3x times 1 is a positive 3x. Then you change the signs. Okay, 3x squared minus 3x squared, gone. 6x minus 3x is 3x, and then this plus 3 falls down. Now, how do I get this x to look like a 3x? I have to multiply it by 3. 3 times x is 3x. 3 times a positive 1 is a positive 3. Then I change my signs. And I do it very dark, as you can see. I make it very dark. I want it to be obvious. Do not forget to change the signs. 3x minus 3x, 0. 3 minus 3, 0. So the answer is 3x plus 3. Okay, 2 more. We have 8m squared minus 2m minus 1 divided by 4m plus 1. Okay, we want to write this in the correct order. Now, how do we get our 4m to look like an 8m squared? Well, for the coefficient, I'd need a 2, right? And for my variable, I need another m. So 2m times 4m is 8m squared. 2m times a positive 1 is a positive 2m. Change your signs. 8m squared minus 8m squared is 0. Negative 2m minus 2m gives me a negative 4m, and my negative 1 drops down. How do I get 4m to be a negative 4m? Well, I only need to multiply it by a negative 1, right? Negative 1 times 4m gives me a negative 4m. Negative 1 times negative 1 gives me a negative 1 times a positive 1 gives me a negative 1. Then we change our signs. Negative 4m plus 4m is 0. Negative 1 plus 1 is 0. My answer is 2m minus 1. Now, these aren't always going to work out to be 0. We will have remainders. I don't want you to think that's always just going to end like that. So let's look at number 6. For number 6, we have 15x squared plus 14x minus 8 divided by 5x minus 2. All right, so How do we get this 5x to be a 15x squared? Well, for the coefficient, 5 times 3 will give me 15, right? They like you to write it over here. And x times x will give us our x squared. So 3x is what we need to multiply by. So 3x times 5x gives me 15x squared. 3x times a negative 2 gives me a negative 6x. Change the sign. 15x squared minus 15x squared, gone. 14x plus 6x now is 20x, and this negative 8 drops down. Okay? Now, how do I get a 5x to look like a 20x? Well, I would need to multiply it by 4. 4 times 5x is 20x. 4 times negative 2 is negative 8. Change the signs. 20x minus 20x is 0. Negative 8 plus 8 is 0. Our answer is 3x plus 4. Okay? Setting these up is the most important part. Make sure you're in descending order of your variables, that the largest one goes first, then the next, and so on. Some of these we'll get to will have 4 or 5 terms. Okay? We need to make sure we're writing them in the correct order. And then we just need to look at the first term. Okay, how do we get this first term to look like this first term? And that's the answer. That's part of our quotient. Okay, multiply it through, change your signs, add them together, and go on to the next step. All right, long division, it's probably been a while since you've done these, so practice them through. Make sure if you need to go through this video again, you do that. Otherwise, if you have questions on it, please reach out to me. That's it for this video. So you can text me with any questions you have. Otherwise, until next time.